couple plans on having 3 children. Suppose that probability of any given child being female is 0.5, and also suppose that the genders of each child are independent. Write out all outcomes in the sample space. So 3 children, you could have all 3 boys, and you could have the first 2 boys and then a girl, or the girl could be in between the 2 boys, or she could be the first and then 2 boys. And similarly, 1 boy can happen in 3 ways. He could be the first of and then 2 girls, and then he could be in between 2 girls, and he could be at the end, and then you could also have 3 girls. So it's this one. The probability associated with each outcome should be, so all these 8 outcomes, 1, 2, 3, 4, 5, 6, 7, 8, all these 8 are equally likely. So each outcome should be 1/8, and 1/8 is 0.125. The probability that the couple will have all 3 girls, so that's only 1 point out of 8, so that's 0.125 again. The probability that the couple will have at least 2 boys, so at least 2 boys are this, 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 and this. So the first 4 points have at least 2 boys, and so it's 4 out of 8, so which is 0.5. Bob is asked to construct probability model for rolling a pair of dice. He lets the outcomes as 2 through 12. Because there are 11 outcomes, he reasoned that probability of rolling a 10 must be 1/11. What's wrong with his reasoning? So what he did was he said that, okay, the possible sums are, the minimum sum would be 2 if both the die get a 1, and then the maximum sum is 12 if both have 6s, and in between you will have all these. And he reasoned that these are 11 possible sums, so a sum of 10 would be 1 out of 11, because that's one possibility out of 11. However, this applies only if all the possibilities are equally likely. Now, the sums are not equally likely, as we can see here if you look here. So for example, rolling a 10 happens if you get 4, 6, that's a 10, 5, 5 is a 10, and 6, 4 is a 10. So there are 3 points that are giving you a 10. And then, for example, if we just look at the 2, there's only 1 point giving you a 2. So a sum of 10 is more likely to appear than a sum of 2, for example. And the same goes for different sums here. So this is not an equally likely scenario that all sums are equally likely. Therefore, you can't do that kind of business which he did, that he said that, okay, these are 10 outcomes, and you just do 1 outcome. These are 11 outcomes, and you do 1 out of 11. So the experiment does not have equally likely outcomes. That's what's wrong with his reasoning. A baseball player hit 71 home runs in a season. The 71 home runs, 22 went to the right field, 25 right center, 12 center, 11 left center, and 1 to the left. What's the probability that the home run was hit to the right field? So right field is 22, and the total is 71. So 22 divided by 71. 0.310. And then to the left field is how many? 11 went to the left. No, 1 went to the left field. So 1 out of 71. 1 divided by 71. 0.014. Was it unusual for this player to hit a home run? Now, our convention in this course will be that if it's less than 5%, then if the probability of something is less than 5%, then it's unusual. Otherwise, it's not unusual. So the probability here is for the left field is 0.014. So if you multiply this by 100, that's 1.4%. So 1.4% is less than 5%. So yes, that is unusual. Yes, because that's the reason 5% is 0.05, not 0.5. So anything less than 5% will be unusual.